Welcome to Chem News, brought to you by the University of Auckland Chem 260 Student Association. Today we will be discussing proteins. You know about proteins, right? Those long, winding strings that make us? Well, it turns out that we need them for more than just the composition of our bodies. They can make really handy medicines. For example, therapeutic proteins are proteins that have been repurposed for helping folks out. Insulin, helping diabetics regulate their sugar levels. Emollient ester is taking care of the skin on our faces. I know atorvastatin would have a thing or two to say about lowering cholesterol if it could speak. However, making therapeutic proteins is hard. It often requires a complicated chemical process involving many types of reactions. Doing these artificially usually requires nasty stuff like high temperatures, high pressures, and/or hazardous chemical solvents. We're just asking for an explosion. This is where biocatalysis steps in. But first, let's join Prokhor, who is asking others about biocatalysis live.
Have you ever heard about biocatalysis?
Oh, yes, I have. I've actually read about it in some of the newspapers, I think.
Hey, have you ever heard about biocatalysis? No. Have you ever heard what biocatalysis is? Never. Have you ever heard about biocatalysts?
I'm not sure.
Have you ever heard about biocatalysis? No, I haven't. Have you ever heard about what biocatalysis is?
Never. No, never.
Hey, have you ever heard about what glycosylate is?
Thanks, Prokhor. Okay, so biocatalysis is used in biology to help us out with chemical reactions. We use enzymes, the little things inside cells that help each reaction occur. Sometimes we go overkill and use the whole cell that contains many different enzymes. Whole cell biocatalysis is nice when a chemical reaction involves multiple steps. We usually need an enzyme for each step in the reaction, and some cells just happen to have all the necessary enzymes. Also, we don't need to optimize the chemical environment for every reaction to proceed. All we have to do is look after the cells, make sure they're properly fed and are having a good time. Now, remember those handy medicines we talked about earlier? Yes, those. Whole cell biocatalysis is used to enhance therapeutic proteins' function through a process called glycosylation. One molecule, a type of sugar called glycan, is attached to another molecule by using enzymes in a whole cell. This increases the stability and bioactivity of therapeutic proteins, making them awesome medicines. Yep. Looks like we have an example of a therapeutic protein made by enzymatic glycosylation coming up.
If you are not familiar with the epoetin alpha, let me acquaint you. This therapeutic glycoprotein helps out with the red blood cell production and certain types of anemia. Epoetin alpha was pretty good at its job. It attaches itself to the erythropoietin receptor well to the place it's meant to, in order to help. However, it doesn't like the chemical environment of human body very much, so it doesn't stay around for a very long time. That's why we made darbepoetin alpha. This dude is just like epoetin alpha, except with 2 additional glycosylation engineered in its backbone. Although it doesn't attach to the EPO receptor as well, it stays around the body for nearly 3 times longer. This is just one example of many more where glycoengineering has come handy.
Wow, welcome back everyone. Seems like biocatalysis has been quite useful in creating therapeutic glycoproteins that help folks with anemia. But wait, there's more. It is described by Professor Bob as a much greener option. In a few seconds, he will join us live to tell us about how green it is.
Taking all of this into account, we could still say that biocatalysis is still a better option for the environment and for profit. But back to the second hand though, we got to think about water usage. We got to purify things, filter things, isolate things, sometimes multiple times. This contaminates a whole bunch of water. Also, the traditional synthesis methods just don't have the specificity that enzymes do. There's normally like a big ass spaghetti mess of derivatization in order to get the final product. Enzymes show rather impressive chemo, regio, and stereoselectivity. Back to the first hand though, the cells themselves and the things we use to feed them are renewable, and the cofactors they use are usually recycled throughout the process. Well, on one hand, we don't have to use these high temperatures and pressures in order to get the reaction going, but on the other hand, we've got to use these really cold freezers in order to store the proteins and stuff. So, is this whole cell biocatalysis thing really better for the environment?
That's the Chem News for today. I'm Tim Syme, and I hope you all have a good day.